This video is going to cover Trig Note 6.1. We're going to be talking about lines, and there's actually going to be 3 different topics in today's notes. Those topics are finding the angle of inclination of a line. Then the second topic we'll talk about is finding an angle between 2 lines. And then the third thing will be if I ask you to find the distance between a point and a line. So let's get started with talking about what the angle of inclination is. So if we talk about a line, the most basic form of a line is, or the most useful form of a line is when it's in y equals mx plus b form. And again, the m stands for the slope or the steepness of a line. So if I asked you to graph that line, you would find the m and you would find the b and plot those on your coordinate plane. So the m is the 2. We typically write it as a fraction, so we can write it as a rise over a run. And your b was -3. So if I plot that, I'd go down to -3 on the y-axis, because that's my y-intercept, and I do a rise of 2, a run of 1, rise of 2, run of 1. And I would connect those dots to make my line. So this graph would look like this. What I want to talk to you about today is finding the angle of inclination. So the inclination of a line is the measure of the angle formed by the line and the x-axis. So the angle formed by the line and the x-axis. Here's the x-axis. Here's the angle from the line. We're talking about this angle right here. We call that theta. That's the angle of inclination. So we're going to try to figure out what that angle is. Here's how we're going to do that. We're going to remember a couple of formulas. So let's first talk about the fact that slope is the rise over the run. Or if we want to use the formula for it, we would take the y values and subtract them, and take the x values and subtract them and divide that out. What we're really doing is, as a rise over a run, a rise is a vertical distance, a run is a horizontal distance, we're talking about the change in y's over the change in x. The change in the vertical distance, the y's, and the change in the horizontal distance, the x's. Okay, keep that in mind. We'll come back to that in just a minute. We also know that tangent, if we're talking about our trig identities, we have talked about tangent as a lot of different things. Sine over cosine, opposite over adjacent. The one we're going to use is the y value over the x value. In other words, the changes in the y values over the changes in the x values. It's the same thing. So what we can now identify is that if the slope is the changes in the y's over the x's, and the tangent of theta is the changes of the y's over the x's, then doesn't that imply that the tangent of theta is equal to the slope? Well, it does, because they're the same thing. So we can have the formula that the tangent of theta is equal to the slope. Another way we can use this formula is if we solve it for theta. In other words, move the tangent over to the other side. So we can also say that theta is equal to the tangent inverse of the slope. So this is 2 formulas that you're going to use to help you either find the slope, or if you're given the angle, or if you're given the slope, you can find the angle. So let's apply that to our graph that we just did. If I asked you to find the angle of inclination for this graph, you would look at it and say, okay, the slope of this graph was m, so if I want to find the angle, I'll use the inverse formula. So the tangent inverse of 2. Plug that into your calculator, make sure your calculator is in degree mode. You would find that's about 63 degrees. So this angle is about 63 degrees. And that's how you find the angle of inclination then. So if I'm asking you to find the inclination for the line, or another way of saying that is the angle of inclination, for here, remember that our formula is theta is equal to the tangent inverse of the slope. So I need to know the slope of this line, so I'm going to put it in y equals mx plus b form. So I'm going to get rid of the x. I'm going to get rid of the 9. want to get rid of the 5. And I would finally end up with negative 4/5 x plus 9/5. So the slope of this line is negative 4/5. Let's plug that into our formula then, if I'm trying to find the angle of inclination. Theta is equal to the tangent inverse of negative 4/5. Again, my calculator should be in degree mode. Typing this in, I'm getting theta to be approximately negative 39 degrees. Alright, well right away, I should notice that there's something wrong with that answer. It's not positive, so I don't want to use it. That leads me to this point right here. We want to, anytime we're coming up with our theta, our angle, we want it to be a positive angle that's coming off of the x-axis. Positive angle coming off of the x-axis. What that means algebraically, or not algebraically, graphically, is that if we have a line like this here that has a negative slope, our slope is going to be doing something like this. Now again, I'm just drawing a random line with a negative slope. Okay, I know it's got to be falling like this. Well, what I just found was the angle going from the x-axis going down. This angle was negative 39 degrees. What I'm interested in finding is the angle from the x-axis going in the positive direction, which is this angle. So if this is negative 39, that means that our reference angle over here, this part would be positive 39 degrees. And again, if I want this angle here, coming all the way around, I would have to do 180 degrees minus my reference angle. And I would find that my answer would actually be 141 degrees. Again, keep in mind that you want theta to be a measure from the x-axis in positive degrees and radians. This is not positive. So you've got to, again, apply the idea of the reference angle here. Our next example is now moving on to the second concept we're going to talk about, which is finding the angle between two lines. So if you have two lines on a graph and you want to know the angle between the two lines, you use this formula. So let's highlight that. The tangent of theta is equal to the absolute value of the two slopes subtracted from each other divided by 1 plus the product of the two slopes. So what you can see in this problem is that in order to use this formula, you need to know what the two slopes are. So that's what we're going to have to do in our example here, is find the slopes of both of these lines. So again, they need to be in y equals mx plus b form. So doing that, we'd move over the x first. We'd move over the 2 next. We'd move over the 3 as our last step, and I would get y equals negative 1/3 x plus 2/3. So for my first line, I would find the m value to be negative 1/3. Do the same process here for the second equation. Make sure I subtract it from this side. Negative 2y plus 3 equals negative x. Get rid of the 3. Divide by the negative 2. This time I'm finding that y would be equal to a negative over negative is a positive, so positive 1/2 plus 3/2. Again, the slope for this second line would be 1/2 then. Okay. Now that I have my two slopes, let's plug it into our formula. Tangent of theta is equal to the absolute value of the second slope minus the first slope over 1 plus the two slopes multiplied by each other. 1/2 times, I guess I should write it the way the formula says. It has m1 first, although it won't matter for multiplication. Negative 1/3 times 1/2. Alright, so the tangent of theta is equal to 1 minus negative 1/3 is 5/6. And let's see, algebraically we would do our multiplication next. We get 1/6. So now this is 5/6 over 5/6. Again, the absolute value of that is 1. and the absolute value of 1 is 1. So what I end up with is the tangent of theta equals 1. But again, if I want to find the angle, really what I want is the theta. So let's move the tangent over to this side by taking the inverse. So the tangent inverse of 1, when I plug it into my calculator, is going to give me 45 degrees. So the angle between these two lines would be 45 degrees. Alright, the third topic of this video is talking about finding the distance between a point and a line. So I invite you to pause the video and graph the line and plot the point. So take a second, pause the video, and graph this, and then come back to what we're going to discuss now. Okay, so now that you've graphed it, what we're trying to do is find the distance between this point and this line. I really want to know what this distance is here. And what I know is that the shortest distance between a point and a line should be this is a straight line. So again, this is going to form a perpendicular line here with this point and this line here. So I want to know what that distance is, okay? So I could go through and I could figure out what the slope is and use the distance formula and do all of that, and that'd be a really long way to go about this problem. The quicker way is to now use this formula, okay? That the distance would be equal to the absolute value of a times x sub 1 plus b times y sub 1 plus c, okay, the absolute value, just the numerator, divided by the square root then of a squared plus b squared, okay? Let's make sure we understand what a, b, c, and x1, y1 is. x1, y1 is just the point. So for our problem here, that's going to be 1, 3. A, b, and c, you'll notice that a is the number in front of the x term. So for our problem, we would think that it would be a 2, but it's not going to be because our problem has to be equal to 0. So the first thing that we want to do is make our problem be equal to 0. So let's move the y over. So now that it's in the right form, a is the number in front of the x, which is 2. B is the number in front of the y, which is now a -1. And c is the number that we add to the end here. In this case, it's a -3. Now that we know that a, b, and c are, we can plug it into our formula. Again, it's key that you make sure that your a, b, and c, you find that when your equation was equal to 0. So you have to do some manipulating to your equation first to be able to use this formula. And a lot of students forget that part. So our distance will be equal to the absolute value of a, which is 2, times the x value of 1, plus b, -1, times the y value of 3, plus c, -3. So again, absolute value of just the numerator, divide that then by the square root of a, which is 2 squared, plus b, which is -1 squared. So reducing this, I'm going to get, in the numerator, I'd get 2 minus 3 minus 3. That would be absolute value of +4. And I'm just noticing a mistake that I made here. No, I didn't make a mistake. Absolute value of -4. And then in the denominator here, it is the square root of 4 plus 1, so it would be square root of 5. So we would really have absolute value of 4, which is 4 over square root of 5. Again, to solve this, what we want to do is, I'm just trying to find the distance so I can give an exact answer, 4 square roots of 5 over 5. Or I can give a rounded answer, which would just be 4 divided by the square root of 5 if I don't go through and rationalize it. So my answer would be about 1.79, or the exact value would be 4 square roots of 5 over 5.